welcome everybody. Today I would like to talk about patient behavior guided nursing in neonatal intensive care unit. I am Judit Varga and work in the second department of neonatology, and our vision is that sleep protective nursing of little babies leads to better neurodevelopmental outcome later and a better quality of life. And our mission is to develop new techniques of automated detection of circadian rhythm and behavior of premature infants and neonates, and also to search for other equipments as well. And we have two projects for achieving this aim. In the first project, we investigate an already existing equipment called Ectographic, which was developed to sleep measurement, and it is used also in children. And in the second project, we intend to develop a new equipment, which is a camera-based equipment for observation of behavior of infants. Let me talk about the first project, which is diagnostic accuracy of ectography compared to polysomnography in children. As a background, I can tell you that the prevalence of sleep disorder is very high in children population, and in those with neurodevelopmental disorder, it is extreme high, we can say. And objective measurement of sleep is essential. And the gold standard of this sleep measurement is polysomnography. It is, however, complicated and requires huge hospital resources, while we have another equipment called Ectography, which is a watch-like device. It is easy to wear and also cheaper, and makes long-term measurements available even at home. And our aim is to assess the accuracy of this equipment in children population. And during the systematic search from about 5,000 hits, we selected 12 articles at the end. In these articles, the studies were designed for direct comparison of the two equipments. And first, I would like to talk about a little bit of the outcomes, the sleep parameters. For example, total sleep time is the time scored as sleep between lights off and lights on events. So the green blocks together. And wake after sleep onset is the time scored as wake between the sleep onset and the sleep offset. So the is the period between the green blocks. And sleep efficiency is the ratio between total sleep time and sleep period time. So how effectively you sleep. And statistical methods are also interesting in this meta-analysis. First, we pulled sleep parameters concordance. That means that we pulled mean differences between the measurements of the two devices. And in this case, mean difference represents the bias between the measures of polysomnography and ectography. But there's another method. This is epoch by epoch agreement, and correlation between sleep parameter is an additional analysis. And in the forest plot, this is the forest plot of the standardized mean difference between the measurements of polysomnography and ectography in the different articles. And polysomnography is the gold standard. So we subtracted the mean measurements of ectography from polysomnography, and And that's why if the ectography, we get the bias if ectography underestimates, you can see it on the right side, and if ectography overestimates, you can see it on the left side. So those articles in which ectography underestimates are on the right side. The heterogeneity is very high, so we rather focus on the confidence intervals, and we can see that there is a significant under and overestimation in most of the studies, and it is the same regarding wake after sleep onset and sleep efficiency as well. And this is the first meta-analysis in childhood, and the subgroup analysis will be conducted according to different age groups, and also with other statistical methods, pooling will be carried out. The limitation is that in the articles there are the circumstances are very different. They use different ectographs, different population, age groups, and different thresholds in ectography. So we see it in the heterogeneity. We have to clean further the data. But it is not easy because non-uniform data reporting hinders the data pooling. And so far, it seems that polysomnography cannot be replaced by ectography in children. It's a pity because it would be an easy-to-use tool. And future research should focus on narrowing the methodological heterogeneity in order to tell the accuracy of this device. The other project is developing a new device, which is a camera-based observation of behavior of infants. We have a camera system that can tell the vital parameters because it is connected to a software which uses machine learning techniques. So it is able to tell you the vital parameters, namely oxygen saturation and heart frequency, and we would like to use it to recognize the different behavioral patterns according to a program called NITCAP. This is Newborn Individualized Developmental Care program. First, we would like to teach this system how to recognize the deep sleep phase. And it would happen in the 3 department of the Semmelweis University, and it would happen on stable neonates. And data would be collected on one hand with the video system, and the other hand with direct patient observation, and also with conventional monitors. And first, we would like to identify the deep sleep phase. Thank you for your attention.
It's a much easier, probably cheaper method than the gold standard, and can be that in not all cases, in not all patients, it's useful. But
Yes.
what do you think? In which cases, in which patient group could it be used even? What kind of subgroup analysis do you plan?
Yes, I plan subgroup analysis according to age, and I also plan to collect data only from healthy patients in the first round, and with the same thresholds and algorithm which these equipment uses, because in the articles there are several algorithms and several thresholds, and they write data observed in one patient in one time with several thresholds as well. So we have to collect it uniformly and clean the data more. We try to do our best, but we can do further subgroup analysis according to these.
Maybe I didn't understand completely, but in your second and third outcomes, Ectography neither under nor overestimated the outcome parameter, right? And in the first one as well, there was no statistically significant difference, just a tendency. And the weighing...
Yes, overall, so if you look at the confidence intervals, they don't reach the zero level where there is no difference, only in some of the cases. So we see that in most of the studies there is a significant difference between the measurements.
Yes, there is, but in overall, what you get is not a significant difference, right? So some studies say it overestimates, some say it underestimates. So I'm asking by the primary conclusion that it cannot replace it, and by the conclusion that it probably neither over nor underestimates, but results are still inconfident.
Yes. Yes. Maybe it's a bit strict. So we have to see by subgroup analysis, and I also think that we can find population in which it is good.
It's a similar question to Felix's. Do you plan to analyze these articles in means of what could have caused these under and overestimates, so you can draw some conclusions and use it in your clinical trial?
Yeah, yes, the same. So with this subgroup analysis, I would like to find the background of it, and maybe. So what is important for us, that is it accurate in neonates or not? But we don't have many data from neonates, unfortunately.